Hello students, welcome back to the online session of physics. In the last class, we covered the topics, the mechanical properties of solids, deforming forces and the restoring forces, and the important elastic behavior of solids. In this session, we discuss the important terms in elasticity that are stress and strain. We are familiar, or you are familiar with the term pressure from the lower class onwards. What is pressure? Pressure is the force acting per unit area. Pressure is a force acting per unit area. That force is the deforming force or the applied force. But in elasticity, instead of pressure, we use another term, stress. Stress is the internal force, internal restoring force per unit area. About the behavior or the elastic behavior of solids, we know that elastic behavior of solids depends on the deforming forces and the restoring forces. Deforming force is the force applied to a body and the restoring force is the internal force. The stress is the internal force developed per unit area. Stress is the internal force developed per unit area of a solid due to that deforming force. The internal force developed per unit area is called stress. A stress notation is S is equal to force divided by area. This force is the restoring force. The restoring force per area. The unit of stress is Newton per meter square. Newton per meter square or Pascal, same as that of the pressure. The main difference between the pressure and the stress is pressure is the applied force per unit area, but in elasticity, stress is equal to the restoring force per unit area by the application of the deforming force. The same unit, Newton per meter square, and the dimensional formula of stress is same as that of pressure, that is mLT raised to minus 2. We will study the dimensional analysis and the dimensional formula and all in class 11, chapter 1, part 1, chapter 1. The dimensional formula means we can represent any physical quantity in terms of mass, length and time. The dimensional formula representing physical quantities in terms of mass, length and time. So we know the formula, force is equal to ma, mass into acceleration, mass m, capital letter M. What is acceleration? Acceleration, the velocity, acceleration, velocity per unit time. Then velocity is the distance per unit time. So you have to find out the dimensional formula of acceleration. Dimensional formula of acceleration is LT raised to minus 2. LT raised to minus 2. MLT raised to minus 2, the dimension of force. Then this is equal to the dimension of force. LT raised to minus 2, the dimension of acceleration. That is velocity divided by time. L divided by time is velocity. Again divided by time, acceleration, LT raised to minus 2. So, MLT raised to minus 2, the dimension of force. Then pressure or stress is equal to force divided by area, force by area. The dimension of force is m L T raised to minus 2 divided by area L square, meter square, so length represented by the letter L. So m L T raised to minus 2 divided by L square. So the dimension of stress is m L raised to minus 1 T raised to minus 2. The dimensional formula of stress is m L raised to minus 1 T raised to minus 2. This is about the dimensional formula that you will study in chapter 1 in detail. Well, dimensional formula of stress is m L raised to minus 1 T raised to minus 2. m L raised to minus 1 T raised to minus 2. That is a small mistake. So, m L raised to minus 1 T raised to minus 2. So, dimension of pressure m L raised to minus 1 T raised to minus 2. Okay. The dimensional formula is m L raised to minus 1 T raised to minus 2. So, stress is the internal force developed, internal elastic force developed per unit area is called stress. Stress equals the restoring force by area. Okay. Types of stress. Next topic, types of stress. The types of stress, first one is longitudinal stress or normal stress. Longitudinal stress or normal stress. Suppose if we apply a force perpendicular to the cross-sectional area of the body, then the restoring force developed per unit area is known as the longitudinal stress or normal stress. Then apply a force perpendicular to the cross-sectional area, perpendicular or normal to the cross-sectional area of the body, then the restoring force per unit area is called longitudinal stress or normal stress. So, consider the case of a cylinder of length L, and if you apply a force perpendicular to the cross-sectional area of the cylinder, its length increases or there is a change in length takes place. That is why the name longitudinal stress. The longitudinal stress is the internal restoring force developed inside the body if we apply a force perpendicular to the cross-sectional area of the body, perpendicular or normal to the cross-sectional area of the body. So, type 1 stress, longitudinal or normal stress. Again, the longitudinal stress is divided into two. First one, tensile stress. And longitudinal, apply force perpendicular to the cross-sectional area. Consider the cylinder and apply force from both sides, equal and opposite forces. That is why the length of the cylinder increases. Consider the case of a rubber cylinder. Its length increases by the application of force. Then if the length increases, then the restoring force developed per unit area is called tensile stress. So, if there is a change in length, commonly we use the term longitudinal stress. Longitudinal stress means lengthwise deformation takes place. The internal force developed in the body due to the applied force if the length of the body changes, that is longitudinal stress. The longitudinal stress is again divided into two types, tensile stress. If the length of the body increases by the application of force, then the internal force developed is per unit area is called tensile stress. Suppose if we apply a force equal and opposite forces in the opposite direction, the length of the body decreases. If the length of the body decreases, then the stress is called compressive stress. In these two cases, the length of the body change, there is a change in length. In the first case, if the length increases, that is called a tensile stress, or if the length of the cylinder decreases by the applied force, that stress is known as compressive stress. So, longitudinal stress is divided into two types, one tensile stress and the second one is compressive stress. So, first type stress, longitudinal or normal stress. Always consider, always apply force perpendicular to the cross-sectional area of the body. Then, second stress, that is tangential or shearing stress. Tangential stress or shearing stress. In tangential stress, the force applied is parallel to the cross-sectional area of the body. So, tangential to the cross-sectional area of the body. It is not perpendicular to the cross-sectional area of the body. We apply a force tangential to the cross-sectional area of the body. That is why a change in shape takes place. The change in shape takes place in the body if we apply a force tangentially to the cross-sectional area. Then change in shape takes place. Then the restoring force developed per unit area is called tangential or shearing stress. In the first case, we apply force perpendicular to the cross-sectional area. In the second case, we apply force tangential to the cross-sectional area. So, shape change is shearing stress. And the third one is hydraulic or volume stress. Hydraulic or volume stress. In hydraulic or volume stress, then apply force equally from all directions. If we apply force equally from all directions, then the internal force developed per unit area is called volume stress. Then by the application of force equally from all directions, its volume changes. The volume changes. So, it is change in volume. It's delta V, original volume V. By the application of force from all directions, the change in volume takes place. In this case, the internal force developed per unit area is called hydraulic stress or volume stress. So, three types of stress: longitudinal stress, lengthwise deformation takes place, and the restoring force per unit area is called longitudinal stress. Tensile, if the length increases, it is called a tensile stress. If the length decreases, it is known as compressive stress. In the second case, if apply a force tangential to the cross-sectional area, then shape of the body changes. That is why the internal force developed per unit area is known as the shearing stress or tangential stress. And the last one is, if you apply force equally from all directions, its volume changes, then the internal force developed per unit area is called hydraulic stress or volume stress. Okay, next important term in elasticity is strain. First term, stress, restoring force per unit area. Next is strain. The strain is a measure of deformation representing the change in dimension of the body related to a reference dimension or the original dimension. So, we know that the actual length of the body, consider the case of the longitudinal stress, actual length of the body is L. The change in length takes place by the application of the force. The change in length is delta L. So, strain is a measure of deformation with respect to the original dimension or original value. So, original length is L and the change in length is delta L. So, the change in deformation with respect to relative to the original dimension is the measure of the dimension. That first is change in dimension of the body. Change in dimension of a body relative to a fixed dimension or relative to a reference dimension, that is known as strain. So, we have three types of stress, that is why you have to consider the types of strain. First one is longitudinal strain. Longitudinal strain is defined as the ratio of the change in length to the original length of a body as a result of longitudinal stress. So, change in dimension related to the original dimension, that is strain, the measure of change in dimension related to the original dimension. So, in the case of a longitudinal strain, the length of the body in longitudinal strain, to consider a cylinder, its length is L, and if I apply a force in the downward direction, its length increases. Its length increases by the applied force. So, this is the original length. The change in length is delta L. So, this longitudinal strain is a change in length with respect to the original length. Change in length with respect to the original length. The change in length is delta L. Delta L by L. Delta L by L is called longitudinal strain. So, this is equal to delta L. Delta L is the new length L dash minus the original length the L. Delta L equals the new length by deformation, new length minus the original length divided by L. This is longitudinal strain. So, longitudinal strain, change in length, ratio of change in length to the original length, that is longitudinal strain. Okay, next strain, shearing strain or tangential strain. Then if you apply a force tangential to the body, the deformation takes place, a shape-wise deformation takes place. So, this length, there is a shape change takes place. Delta x is the vertical displacement by the applied force. So, this is our body. If you apply a force tangential to this cross-sectional area, the shape changes. If in the case of a rubber cylinder, its shape changes by the application. So, there is a change with respect to the original position. The vertical displacement is delta x. The change in theta is vertical displacement with respect to an angle theta. The angle theta, so consider this triangle, and we know that the length is same in this side and this side. So, no change in length. So, no change in length in, to consider the length of the body is constant. The length by the application of tangential force, there is no change in length takes place. There is a shape change takes place with respect to an angle theta. So, by considering the figure or from the figure, tan theta equals opposite side by adjacent side. Opposite side is delta x. Adjacent side is equal to the length of the body. So, delta x by L, that is a measure of the shearing strain. It is a measure of angle theta. Angle theta is a measure of shearing strain. So, angle theta, for that consider the tan theta, opposite side delta x divided by length L. And we know that there is a small change takes place, very small amount of shearing takes place on the body. But for small values of tan theta is equal to theta. For small values of theta, tan theta is equivalent to theta. Therefore, that for small values tan theta equals theta. So, theta theta is equivalent to delta x by L. The measure of angle theta due to the shape change. Shape change is the measure of angle theta. Theta is equal to delta x by L. The shearing strain takes place due to the application of the shearing force or the shearing stress. Okay. Last type strain is the volume strain or the hydraulic strain. So, in volume strain, it is the ratio of the change in volume to the original volume. And if you apply force equally from all directions, its volume changes. The change in volume is delta V and the original volume is V. The ratio of the change in volume to the original volume is equal to the volume strain. So, volume strain equals delta V by V, that is equal to V minus V dash. V is the original volume, V dash is the new volume by compression, V minus V dash divided by V, that is equal to the volume strain. So, these are the types of stress and strain: longitudinal stress or normal stress, shearing stress or tangential stress, and volume stress or hydraulic stress. And about strain, first one is longitudinal strain, and the second one is shearing strain, and the third one volume strain. The next one is a relation between stress and strain. The important terms in elasticity are stress and strain. So, there is a relation between stress and strain in elasticity, that is Hooke's law. Hooke's law states that, Hooke's law in elasticity states that within elastic limit, stress is directly proportional to strain. Within elastic limit. Elastic limit, what is elastic limit? It is the upper limit of the body deforming force, upper limit of the deforming force, up to which when the deforming force is removed, the body regains to its initial condition. So, what is elasticity? If you apply a force, deformation takes place, and if you remove the applied force, the system returns to its initial condition. Now, there is a limit for that applied force. Up to that limit, if we apply a force and after the removal of the force, the body returns to its initial condition. So, that shows elastic nature. Otherwise, if we increase the strength of the applied force, the body cannot regain to its initial condition, or plastic deformation takes place in the body. What is plasticity or plastic deformation? It is a permanent deformation. Permanent deformation. So, there is a limit, upper limit of the deforming force, up to which when the deforming force is removed, the body regains its initial condition. So, that is why in Hooke's law says that within elastic limit, if the body is within the elastic limit, that means if you remove the applied force, the body returns to its initial condition. Within elastic limit, stress developed is directly proportional to strain. So, the basic Hooke's law is the force is directly proportional to extension. The basic Hooke's law says that force, what is force? Force F proportional to x, force proportional to displacement. But in the case of elasticity, instead of force we use stress. Stress is the force per unit area. The stress proportional to strain, strain the deformation, measure of deformation. So, Hooke's law states that within elastic limit, stress is directly proportional to strain. The stress is equal to a constant, that constant is known as proportionality constant. It is proportional to strain, therefore, there is a constant K, proportionality constant into strain. The constant K of proportionality, that constant, proportionality constant is known as modulus of elasticity. So, from Hooke's law states that stress proportional to strain, stress is equal to K into strain. K is called the constant of proportionality, is known as modulus of elasticity. So, from Hooke's law, we will get the expression for modulus of elasticity. K is the modulus of elasticity. K is equal to stress divided by strain. Stress by strain is the modulus of elasticity. So, modulus of elasticity gives the measure of elasticity. Modulus of elasticity is equal to the measure of elasticity. So, stress proportional to strain, proportionality constant is K, K into strain, but K is known as the modulus of elasticity, K equals stress by strain. So, in the upcoming sessions we will discuss about that proportionality constant, different types of proportionality constant, modulus of elasticity, different types of stress and strain are there. Therefore, there are 3 types of modulus of elasticity also there in elasticity. So, we will discuss it in later. So, stress is equal to K into strain, K is known as modulus of elasticity. So, 3 types of stress are there, and that is types of strain, longitudinal strain, shearing strain and the volume strain, and the relation between Hooke stress and strain is Hooke's law. It is about elastic limit. Elastic limit is the upper limit of the deforming force. Up to that limit the body shows perfect elasticity. So, next numerical related to an equation stress equals force by area. Consider this one as question number 9 and the exercise question. A steel cable with a radius of 1.5 centimeter supports a chair lift at a ski area. If the maximum stress is not to exceed 10 raised to 8 Newton per meter square, what is the maximum load the cable can support? The maximum force the cable can support. The steel cable with a radius of 1.5 centimeter supports a chair lift at a ski area. If the maximum stress is not to exceed, the maximum stress equals 10 raised to 8 Newton per meter square, find the maximum force on the cable. So, we know that the relation stress is equal to force by area, restoring force by area. Then therefore, the maximum stress is equal to the maximum force by area, maximum load divided by area. The maximum force or the maximum load that can be applied to a body, maximum force is equal to maximum stress into area. The maximum stress into area, the stress is 10 raised to 8 Newton per meter square, and the area, cross-sectional area of the cylinder, cross-sectional area of the cylinder is pi r square, then 10 raised to 8, 3.14, pi value 3.14, then 1.5, radius is 1.5 centimeters, so represent it in meter, 1.5 into 10 raised to minus 2 meter, the whole square. The answer is 7.07 into 10 raised to 4. What is the unit? Unit of stress. Unit of stress is Newton per meter square. Sorry. Okay, you have to find out the force. Force here. Force Newton. The maximum force is Newton. The unit is Newton. So, by using logarithm, you can find out the result using logarithm. So, how can we apply logarithm to that question? You know that the equation is stress equals force by area. Force by area. So, you have to find out the force. Force is equal to stress into area. Stress into area. Here stress, the value of stress is 10 raised to 8 Newton per meter square, and the area is pi r square. So, this is equal to 10 raised to 8 into pi value 3.14 into 1.5 into 10 raised to minus 2 square. Okay. Then consider the power of 10 together, 10 raised to 8 into 3.14 into 1.5 square